this one. The big idea is you don't wanna judge it, you know. Let me see here. Let's not do this for the sake of, let's see. You don't wanna judge a question based on what you see at first glance. So what we're seeing at first glance here is, our variables as exponents, which is like, oh my goodness, So the issue now is, you can just do what you can. Like, for example, the left side here, it doesn't look like anything can be done there, but it does look like the right side. We may want, like, maybe simplify it a bit, make it look a bit different, and then we can see how these two can align with each other. So let's take this equation here. There's like 4 to the power of y, and the whole thing is to the power of x, right? And then this is equal to like 1/16. And then from there, you want to almost think to yourself, what do you see from the other one that the second one might have? Oh my goodness, I'm getting this call. Oh God. Do you mind if I just take this call?
Oh, yeah, it's cool. Take it.
Thank you. Okay, I'm back.
Woohoo!
Yeah, yeah, it's hectic, ma'am. Very hectic this side. I don't know how it is on your side, but
I
here,
wish for a kind of hecticness, I well.
what? You wish for what?
I wish for your kind of hecticness, I well. Means you have a
Oh,
life outside of all of this, bruh. I
lol, dude.
well.
What the hell? This is Sibaweli. Oh, swivel. Don't even. Don't even. Ish.
Why
Yeah.
not though?
No, I'm like, there's really nothing to Yeah, it's not okay. It's not bad hectic. It's just like, ish. Yeah.
Exactly.
It's just like a lot. And it's like, yeah, man. Like, dang it. Like, oh, how in the world? So let's quickly maybe go through this. So that we can, yeah. So from what I was saying, oh, did I even pause this recording? Oh no, I didn't. Useless. Yeah, ne? Yeah. Anyway, so it says here. So what I'm trying to say is, you see the way this looks now, it looks a bit strange. But you may want to, instead of working with just both of them together randomly, you want to give yourself a chance to like see what you can come up with from here. Like for example, here, this is already like 2 to the power of 2 with y, right? And then the whole thing to the power of x. You see?
I see.
Yeah. Now or rather, let's not even like let's not do things randomly, because now the issue now is I've said to myself, okay, I wrote this. What was the reason? And there's not like a direct reason. So I think what may be practical is looking at what we have here, right? It looks like we cannot do much yet. We could have therefore to the power of y to the power of x, right? Equal to 1/16. And then because there's a 4 here and we're dealing with exponents, we may want to write it as 2 to the power of 2 with yx. And then we may want to eventually say something like 2 to the power of 2y x, like this. You see?
Okay.
Yeah. So with our second equation, this looks like fine, something we cannot necessarily do something about yet. So what you want to then do is you want to see, okay, fine, where you've ended up here. Let's see what can be done with the second equation. So there's like 2 to the power of x here, 4 to the power of y equal to 1. So this is like 2 to the power of x, and then this is 2 to the power of 2, right, with the y there. And then you already know that this is like 2x dot 2 with 2y equal to 1. Do you see? Yeah. And remember, the law with all exponents, your exponential laws will tell you that if your bases are the same, you need to add your exponents, correct?
Yes.
Yeah. So now this is telling you if your bases are the same, right? And you're multiplying, so this is going to give you what you may call 2 with x plus 2y equal to 1. You see?
Yes, I see.
Yeah. So with these kinds of questions, right, this is where creativity needs to come in. When I say this is where creativity needs to come in, I mean, whenever you work with an equation, right, and you're dealing with variables where your variables are an exponent, what you want to do is you want to see if you can make sure that both sides can be written in terms of an exponent. So the fortunate thing is 2 to the power of anything, 2 to the power of this is equal to 1, right? Now, fortunately, we know that 1 is the same as 2 to the power of 0, or rather anything to the power of 0 is a 1.
Yes.
Yeah, anything to the power of 0 is a 1. So what you can put is on the left, you can put 2 to the power of 0. And then from here, you are able to isolate a value for x or y, preferably x probably, that you can now
Yes,
throw in
preferably.
there and you can carry on with your question. You get.
Yes.
Yeah. So let us do that. So with what we have down here, right? With regard to what you may call this, what we have here. Yeah. So with all that we have here, we can just solve for this here. We can just not worry about the bases because you only consider your bases if it's like necessary. For now, we're trying to work with exponents. So here you can just disregard the bases and then work with just the exponents, because if these two sides are going to be equal to each other, it's the exponents that need to be equal to each other because the bases are the same anyway. So all we need to deal with is the exponents over there. Do you see?
Okay, run it back. Run it back.
Yeah, let's run it back. So what we're saying is, firstly, the two sides here, the things that match is this is 2, this is 2. You see? Yeah.
I see.
So if these two sides are going to be equal to each other, the top part here has to be equal to the top part here also.
Okay.
Yeah, because the bases are already equal, you see. So the only hindrance here is the what you may call the top part, because the bases are already the same. So if this equation is gonna balance, we just have to consider the top because the bases are already the same anyways.
Okay.
Yeah.
Okay.
So and that's like the law of solving for x or anything like that. If you what you may call, that's the law of solving for x if you're dealing with exponents. You get?
Okay, I hear you. Yeah, I hear you.
Yeah. So from here now you've basically put yourself in a position where you now have what you may call a simple equation where you can now do what you normally do, like solve for x here and then throw it into your other equation. You see? Do you see?
Yep, I see it now.
Yeah, so here x is just equal to negative 2y. And then you can label this equation number 3. These other equations here, this was like equation number 1. No. Whatever, yeah. So here, whatever we have now, right? We can throw it into this equation over here.
That's equation number 2.
Yeah. Remember, with this equation, we stopped here. We couldn't do anything. Yeah. So then, with everything that we had done, we stopped here. And then now in our second equation, the furthest we could go was here now.
Okay.
Yeah, so we're just going to take this x and we're going to throw it into that other equation. Cool.
Cool.
Fantastic. So let me just copy this thing here, actually. Do this. Let me copy. And let me paste.
Can I just pause you here for a quick second? I just need to do something. I'll be back.
100%.
You. Hey, kids. Answers from so good. Okay, I'm back.
Good stuff. Good stuff. Okay, yes. Let's see here. Let's see. Okay, yeah. So from where we were now, right? We said here now we need to take this here. We need to throw it in there. So wherever x is, we need to throw this thing. So here we're gonna have 2 with 2y, and then we're gonna have negative 2y here, equal to 1/16. You see. And then let's see here. What else are we gonna then do now? So from here now you're gonna have like 2 with negative 4y squared equal to 1/16. You see? Perfect. So here now, this is also giving us another opportunity to what you may call. It's giving us another opportunity to showcase another trigonometry law. You see. So, oh no, trigonometry. Did I say trigonometry? Another algebra law. You see. So when it comes
I was
to like,
wondering about that.
yeah. So when it comes to algebra, right? The idea is normally when an exponent is to the power of a negative value, it will always be a fraction, you see. So all you would want to do now is you want to actually solve 2 to the power of what as a negative is going to give you a 1/16. So you can usually just take your calculator, and then you can almost do it like using like trial and error, you know. So here on this side we have 4 with y squared, and then on this side it's going to be 2 to the power of a negative number. So to find that negative number, fortunately you can legit just use trial and error. So you can put there 2 to the power of negative 3. It's not giving you 1/16. 2 to the power of negative 4, yeah, it's giving you 1/16. You see, so you now know that the exponent that is going here is just a negative 4. Maybe use the normal blue color. You see, because whatever we have here, our next line looks like this. You get
that actually looks much neater than what I had in mind.
Away. Let's see. Let me see here. Yeah. So with the next step, we're able to do exactly what we did here. You see, the bases are exactly the same. So all we have to focus on is what's on top. You see. So it's just this here is going with that. So negative 4y squared is equal to negative 4. And then solving for y here, you can see we just have to divide both sides by the negative 4, negative 4. And then this is giving us y squared equal to 1. And then you can just square root both sides, square it here, square it there. Y is equal to plus or minus 1. So this is also showcasing another algebra law, you see, keeping in mind that you need to put plus or minus wherever you put something under square root. You get?
I'm good.
Yeah. So let's see here. So with everything that we are doing, you need to keep in mind that now that we have a value for x here, right, or a value for y rather, we can now just throw it into any of our equations to get x. You see, like we can choose to do it with this one. See, or let's maybe take one from. You may think to yourself, why aren't we not using ones from up here? You don't have to. You can always use whichever equation has x and y. That's the easiest one to work with. Of which this one seems like the easiest one because it's already like, you know, all nice and all that. So we're going to start with the positive 1 first. So if you're going to put a positive 1, let me just roll off this thing here. So here it's going to be like x is equal to 2, negative 2 with a negative 1 there. This is like 2. So x is a 2. And then for the positive 1, you would have here x is equal to negative 2 with a 1. So this is x is equal to -2. There we go.
Huh.
So now you have two answers for x, two answers for y.
Why?
You can now just double check with like the main equations. You can just choose whichever one looks the simplest one. Let's choose this one. 2x, 2 to the power of x, 4 to the power of y. Just put here 2 to the power of x, 4 to the power of y equal to 1. So let's try the -1 and the +2. So x is a 2, y is a -1. So this is going to be 4 over 4, which is just a 1. Of which this you can just put in your calculator. It's going to come out as 1.
Yes,
Yeah,
it does.
yeah. The other one, same thing. If you try 1 and a -2, you know, x is a -2 there, and then y is a positive. What is y again? Y is a +1.
Gives you a ones as well.
So this is going to be like 4 over 4 equal to 1, like that. So your answers balance out. Everything is all good. So you can just carry on.
The balance out, everything's all good.
Yeah.
It's just a little overwhelming.
Just what?
It's just a little overwhelming. It was like, pa, pa, pa.
Yeah. So this is one of those really, edgy kind of questions. Meaning, you can imagine the plan is to be going through as many papers as possible. So this is to say, if you bump into these kinds of questions, it's either you don't want to crack your head over them because they are not common anyways. But then the idea here is showcasing, for example, things like how exponential laws, they'll always just come back.
Wow.
Yeah.
Yeah.
Yeah. So I think for now, that should be that. Remember what we said, right? This is what you want to focus on. Let me actually save this PDF file because this is at least one of those PDF files where you want to just like work with it. You want to use it and then like check the steps of like what we spoke about so that you can implement those steps. Oh,
Yeah, that's cool.
fantastic, 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 fantastic. So anyways, that's that for now. This boy needs to remove before this boy gets in trouble. So it's all good now.